We will begin our consideration of calculus by starting with the idea of tangent lines. Typically, you first encountered the idea of a tangent line in geometry. And in geometry, depending on how nuanced your teacher may have been, a tangent line had to do with a line that intersected a circle or grazed a circle or something of that sort at only one particular point. And that was contrasted by a secant line that intersected a circle at 2 points. And this idea is well enough, but it causes all sorts of confusions when we attempt and begin to talk about tangent lines in a context other than circles. Because you can see with a circle on both sides of the point of tangency, the circle is moving away, so to speak, from the line. But that isn't the case in terms of curves, and so there's a misunderstanding that can develop that we want to unpack. So the first thing we want to unpack is that a tangent line is not a line that crosses a curve at exactly 1 point. Or, as you can see, if we have a curve that looks something like this, although it intersects the curve at only 1 point, would not be considered a tangent line. So this is not tangent, although it intersects the curve at only 1 point. Second misconception is a situation where you have a curve, maybe a lot more developed, right, doing something like this, and a person would be tempted to say that this line is not tangent because it intersects at more than 1 point. And this is an incorrect statement. We are looking at a line that is tangent to a curve, and it is tangent at this point. It happens to not be tangent here, but it is tangent here. Right? So it's not simply a matter of intersection at one and only 1 point. It has more to do with the features graphically with what's happening. Right, so again, the left-hand side here would be an example of a line tangent to a curve at a point. And the right-hand side would be a line that is not tangent to a curve at that point. Right, another misconception that occurs, although this one's a little less frequent, would be a situation like this where you have a line that is touching a curve. Perhaps it's even just a ray. And this is not a tangent line. And finally, the idea of just grazing the curve at a point but does not cross the curve is another misconception. Right? So this is a third example. Oops. Color. Where the curve like this, let me flatten this out a little bit. It's acting maybe in this way, where it's just grazing it here, so to speak. The grazing isn't the issue either. Right? Someone might say that that line is grazing the curve there. And the issue isn't one of grazing. So we're not going to formalize our definition of what a tangent line is at this point. We're really trying to just break down some misconceptions. And I would really point you to the second example as being maybe the most important, because you can see in a simple picture a contrast between something that's not. So again, this is not tangent at this point. And the second part, this is tangent at that point. So then for practice, just to help you think about this a little bit, we're going to have you graph equations and then draw tangent lines at the indicated point. So for example, a person could ask, well, let's look at the graph of y equals negative 2x. We know that that's a linear equation with a slope of negative 2 passing through the origin. So it's looking something like that. That would be the graph. And at the point x equals negative 1, so that would be right here, sketch in what the tangent line must be. And at this point, the tangent line could be something like this. Now we could look at something else like a parabola. For example, y equals 1 minus x squared. So this is a parabola that is opening down and has a maximum value at 1. So it's a rough sketch looking something like this. And at the point x equals 0, what would the tangent line look like? Well, in this case, the tangent line would look something like that. Right. Let's consider some other things like a cubic. So this might be something like y equals x cubed minus 3x squared plus 3x minus 1. So if we were to graph this cubic, it's going to look roughly something like this. And in this question, it's a case of x equals 1. And so a tangent line at this point may actually look something like this. Now, some things to notice, because you may be wondering, well, how in the world are you even coming up with these? Some of these even fit the misconceptions. So one idea to keep in mind is that if a line is tangent to a curve at a point, then the slope of the line and the slope of the curve at that point will be the same. Right, so a line is tangent to a curve at a point. If their slopes are the same. If the slopes at that point are the same. And the question that should follow from even that statement is, only linear equations have slopes. Parabolas don't have slopes. Cubics don't have slopes. And this is true in a sense, although you might consider this idea, that a line has a slope, a linear equation has the same slope at every single point. But a parabola, for instance, would exhibit different slopes at different points. That's the idea that we're getting at here. Let's consider one more thing. We'll skip down to y equals the sine of x. Y equals the sine of x is a curve that looks something like this. And the question is, what's happening at x equals pi? So that would be this point here. And what I see is that this should have a negative slope because the curve is going down at that point. So the tangent line should look something like that. Again, we're first having you just think through the idea of what it means to be tangent at a point.